I'm Josip. I'm a platform engineer at Ziverge. I'm part-time CTO at Kodept. I'm dad and I'm a husband. Today I will show you how we can build Kubernetes operators using Scala and ZIO. Let's go through our agenda today. So first we will see what is the operator pattern. After that we'll see what are the operators in Kubernetes. And then we will go with implementing our own operator using Scala and ZIO. Go is today lingua franca of Kubernetes. Kubernetes itself, kubectl, Kubernetes itself, kubectl, kops, helm, and many more are implemented using Go. So is there any hope for Scala there for innovation in that space? I'm saying yes, and we will see how we can do that. So let's see what is the operator pattern. We use operator pattern to to solve a problem how to manage some kind of state and resources. It reduces amount of hard, tedious, boilerplate, and error-prone work, such as deploying your services, backing up databases, scaling your services, or updating the Kubernetes cluster. Operator in itself has knowledge how to manage that resources, and you as a user just need to define some declarative state, and then operator makes sure to apply those changes to the world so that your resources and app are in the state that you desire. Operator also makes sure to keep your state and resources healthy so that there are no any drifts in your system. So basically, you have your operator code, your service that watches some kind of declarative state. It applies changes to some resources and reports back some kind of status. In Kubernetes, we have operators that are watching some kind of external events, cluster state, custom resources, and then they reconcile the cluster to be in desired state. So we can, for example, take a look at a deployment controller or deployment object to see what does this image mean. So in Kubernetes, when you want to deploy your service in a cluster, you define the deployment, which says how many instances of your service you want to have up and running, bounded by some kind of bounded by memory and CPU. You define that in YAML and then create that object in Kubernetes using kubectl or Kubernetes API directly or Helm. And then deployment controller watches the events on your resource deployment and make sure to spin up the services in the cluster bounded by memory and CPU. So you have external events, state, and resources, which are watched by your controller, and it reconciles the cluster to be your desired state. Custom resources definitions are the way how we can extend the Kubernetes API to tell Kubernetes what kind of state we want in our cluster, and then later controller should know how to reconcile into that state. We will now implement our operator. It's an external secret operator. What it will do, it will sync the secrets from the AWS into the Kubernetes and create Kubernetes native secrets so that they can be used from your services. You can see that something like that is useful because it reduces the amount of manual work that someone who operates cluster needs to do. It can be error prone. You can miss some part of your secrets, and a pattern like this is very helpful. So our controller will watch external secret, talk with the AWS Secret Manager API, and create Kubernetes secrets. Okay. Just a second. Okay, so this will not be live coding, it will be more live commit navigation and the live deployment. So I created the project that has two sub-projects. One of them is operator. In that project, we will see how we can implement our operator. Another one is the login application. That's a ZIO HTTP server that exposes one endpoint that we can use to authenticate and test the synchronized secrets into our cluster. So nothing major. It reads the secrets from the file system. In Kubernetes, you can give your secrets to your pods in a few different ways. One of them is to mount it as on the file system. That approach is good because when you change something in your secret, it will be reflected directly into your file system, and you don't need to redeploy or restart your pods. Our operator project for now only exposes health endpoint, so that Kubernetes knows that it's up and ready. Okay, let's jump to the next part. In this part, we need to define our custom resource definition for external secret. So we are doing that in a YARN, nothing special. You need to define a schema of your API object. Our external secret will have its name, specifications such as the type of secret that we want to create, the status that it will show to user, and some additional columns that are not that important. When you create the custom resource definition in Kubernetes, you get a new API. And to communicate with it, we need some kind of client. Vivo created a great library for that, and we can use it to generate a client from the YAML specification using the ZIO Kubernetes CRD plugin, and we need to provide it the path where we keep our custom resources. So basically, you just need to add that plugin, specify path, and it will generate sources for you. When you start your application, it will be good to register that resource so that you can be able to communicate with that API. The library also has a helper method for that, so you can register your custom resource, and you have your API up and ready. Next thing that we need to do to have our operator implemented is to implement the operator control loop. So in ZIO Kubernetes, we are doing that by implementing the event processor. That's basically the function from some kind of event on your custom resource to the code that will reconcile your cluster. You can see it here, so we can react on resetted, added, modified, and deleted events. Today we will implement added and deleted events, and when we see that external secrets is added, we will create a Kubernetes secret, and when it's deleted, we will also delete Kubernetes secret. Modification we will not do today because it's not currently important, but to make this operator even better, for example, you can add ways how to filter some secret fields from your AWS secret, and when you do that, you can react on modify events. Okay, so now we need to implement our create a reaction on added event. What we will do, we need to get the name of our external secret. That will be a link for us to AWS secret. We need to get a namespace so that we know in which namespace we will create Kubernetes secret. It's going to be the same namespace where we have our external secret. Then we need to get AWS secret from AWS, create Kubernetes secret, and update status. So from these helper methods, you can, from its signature, you can see what is going to happen. So get AWS secret will has a secret manager as dependency. That's the API that we need to communicate with AWS. So you know that it's going to call it and get secret back. Create Kubernetes secret will requires the Kubernetes secrets API to create a secret, and update status will update status of external secret, and it needs external secret and clock. From that you can see that it will also update status with last sync timestamp. Okay. So let's see how we can implement get AWS secret. We are doing that by using ZIO AWS library. That library is auto-generated not in the same way like the ZIO Kubernetes, but both of them are auto-generated, and we will later talk more about that. We use its module pattern to get its accessor methods, and then we just need to retrieve secret by secret name and return it back. Our create Kubernetes secret parses that JSON to the map and puts it inside of Kubernetes secret object and calls the Kubernetes API to create secret. In the end, it will get the current timestamp to update the external secret, move it in status that is synced, and add that timestamp there. So let's deploy our operator and see how it works. To create it, to deploy it, I created YAML specifications where you can see all the objects that are needed to deploy your operator, things like service account roles, deployment services. So let's deploy the operator. Okay. In top left screen, you can see a list of running pods. So we deployed external secrets. It's now ready. We can take a look at its logs. Okay, it's listening on 900. That's the port where it exposes the health endpoint. In bottom left screen, we are watching the Kubernetes secrets and also external secrets that are in the system. Currently, we only have this service account token. Let's now create one secret. Let's first take a look how it looks like. Okay, that's a secret that has a name function Scala. Its type is opaque. There are a few different types of secrets in Kubernetes. Opaque is a general one. You can also specify something like basic out secret that will check that if you have a username and password, something like to ensure type safety. Let's also see our secret in Secret Manager. So that's a secret that has two fields. It's username and password. Okay, we will change this to this here. And let's now create the secret. Okay, we see that that external secret is created. That represents the state that we want want for our cluster to be in, and we want it to synchronize AWS secret in our system, and it has done that. We can see it here. Let's also deploy our application, login application, to see. Okay, let's see if it's up and ready. Okay, it's taking some time, and it's up and ready. Let's try to log in. First thing, we need to export, port forward the port of our login app and try. Okay, cool. It managed to authenticate. So you see that in a few easy steps, we have a Kubernetes native application using Scala and ZIO. That can be very useful. But we're still missing some features, so let's add them. The first feature that we are missing is we would like to, give an operator a way how to delete a secret that is synced from AWS. We will do that by reacting on the delete event of the Kubernetes operator. So that's again nothing complicated. It will get the name of the secret, get a namespace, and just call Kubernetes delete API on secret API object. Let's deploy this version. First, we need to clean. Let's also delete secret that we synced. Okay. New version of operator will support reaction on deletion events. Let's create our external secret. Okay, we can see that it's created. And let's now delete it to see if operator will delete it. Okay, we have that functionality too. Okay, now our operator is even better. but there is still one issue that could make life tougher for our Kubernetes, for our operator, and that's when secret on AWS changes. It would be good to get that event and propagate it into Kubernetes system. We can also easily implement that part of cluster operator reconciliation of the state is, if you remember, that watching of the external events. So let's implement that. Okay, so that's something, again, nothing too complicated. We need to do basically the same thing as for creation. We need to get a secret, replace it, and update status. But before that, we'll get all the existing external secrets so that we know how to, which secrets to sync again. And we will repeat that action every 5 seconds. Let's deploy it. A few more seconds. Come on. Yeah. Okay, let's wait for it to be ready. Let's import the secret again. Okay. Let's log in. And let's now change our secret on AWS. Okay, after a few seconds, but it should be visible inside of our pod. But in Kubernetes, there are 3 ways how you can refresh mounted secrets. Didn't have time to customize it to always call the get endpoint of the secrets, so it's going to take a little bit more time, probably up to the minute. Let's see. Okay, it's still unauthorized, but we can check that after a little bit later. So you can see now that we can build easily using a Scala and ZIO useful operators in Kubernetes. I'm very happy because of that and for the opportunity to innovate in that space in such a simple way. Go is a great language for me, but again, speed it's really hard sometimes to write something useful in it. So this kind of experience is great, and I think that we can make it even better. For example, build some kind of mini framework that will give us a way how to generate scaffold a project, how to easily deploy our operator into the Kubernetes in production or on local servers so we can test it easily. And if you are interested in something like that, let me know. You can find me, just a second. You can find me on Twitter and GitHub and handles at ZIO K8S, and on the mail Josip.Grgurica at Ziverge.com. Let's just check if the secrets was synced. Yeah, it is. So we have whole functionality in less than 30 minutes. I would like to say thank you to John, Sandra, Itamar, and Adam for giving me this opportunity to talk here. I would like to say thank you to my colleagues at Ziverge, Chronologics, and Codept, and especially say thank you to my family, especially my wife, who is home with our baby, and it's really tough to take care of him when there are 2 of us, and now she's alone, so I'll be back soon.